beautiful people, and welcome to Teaching Sylvanas Math. Today we're going to be talking about how to solve a multi-step equations. And there is a video already posted on how to solve one-step equations. In the beginning of that video, we talked about the operations that you need to know, the mathematical operations like addition, subtraction, multiplication, division, and how those will come up in an equation. We also discussed the importance of knowing your inverse operations, so like the opposites, the operations that undo certain operations. For example, addition, the inverse of that is subtraction, multiplication, the inverse of that is division, and then vice versa. So make sure you head over there and watch that video before starting this one. Now, for solving multi-step equations, we're going to be doing lots of things. Okay, we're gonna jump right in, and we're gonna start off with a few examples, and then I maybe will point out some steps in the middle. But let's just get started. As always, a disclaimer: if you notice a mistake, please let me know where the mistake occurs, so that way we both can learn from my mistake and I can fix it. Also, if you hear anything in the background, we are recording from home today. So if you hear anything in the background, that is Miss Sylvanas running around having a great time in the background. All right, let's get started. So let's do example number 1. And let's start out with something that doesn't require too many steps. But let's do something like negative 4x plus 3x is equal to negative 4. So kind of our steps. Step number 1 is always going to be the same. Step number 1 is always going to be the same. Is you're going to draw a vertical dotted or dashed line from your equal sign. And what that is, it will separate your equation into 2 sections. So this is going to be your first section, this is going to be your second section. So all of these steps that we do can only be done in the section, or if you want to move things from one section to another, you'd have to use the inverse. And I'll show you how that's done. So step number 1, draw a vertical dashed line from your equal sign. Step number 2, I'm going to have you look at each section and combine like terms. If you're struggling to know what like terms are, go ahead and head over to that video. It should be titled Combining Like Terms. Go ahead and watch that, pause this video, take a break, watch the other video, and then come back to where we are at. So step number 1, draw a vertical dashed line. Step number 2, look at each section and combine like terms. So I'm going to look at this left section here, and I notice that I have negative 4x's and I have 3x's. So since both of these terms are x's, I'm going to go ahead and combine them into one term. So what that means is I have one term, 2 terms. I'm going to combine that into one term. Okay. So again, if you're not sure how to do this, go ahead and head over to combining like terms. So I have negative 4 and 3. So that means I have negative 1x. Now you don't have to write 1 in front of x. I'm doing it for a reason. And then is there anything to do on this side? There is not. So I'm going to bring that down and say negative 4. So our objective is to solve for x. As of right now, x is not by itself. So I'm going to go ahead and put the step number 3, put your variable in a bubble. So here's your variable. I'm putting it in a bubble. And so get rid of everything attached to your variable. And I'm going to say that undo everything. And again, everything we're talking about on that side. So again, we're going to undo everything attached to your variable. And so what that means is you're going to do reverse PEMDAS. So instead of going PEMDAS, we're going to go PEMDAS, meaning sad PEM, sad PEM. It's a sad PEM. Okay, so we're going to start out and see if we have any subtraction, any addition, that is a plus, any division, any multiplication, exponents, and parentheses. So those are going to be your steps to have how to undo it. So do I have any subtraction? Well, I have a minus here, but it's not subtracting anything because how are these two things attached? How is it attached? How is this -1 attached to this bubble? Well, it's attached to this bubble by multiplication. We know that because mathematicians are lazy and there's a hidden dot there. So what I truly have is I have a -1 times x here. I still have that -4 on the other side. So I'm going to say I have multiplication. So how do I undo multiplication? By division. And I'm going to divide. So here's x in my bubble. I'm going to divide by exactly the same thing that's being multiplied. So if it is being multiplied by -1, I have to divide by -1. So I have this, and I'm going to divide by -1. I have this, and I'm going to divide by -1. And then what does this line represent? This line represents an equals. If you watched my reducing fractions video, you'll notice that we have a -1 on top, we have a -1 on the bottom. That divides out to just 1. So what do we have here? We have x. 2 negatives make a positive. 4 divided by 1 is just 4, and we have solved our equation. Now, undo everything attached to your variable. We've done that. And then I'm actually going to add a few steps because although these steps work for this example, I want to make sure that these steps work for all examples. So I'm going to add a step number 5. And step number 5 is move variable to one side and numbers to the opposite side. So what that means is, here's my variable, it's on one side. So my number without a variable has to be on the opposite side. So move the variable, and I'm going to put variables, but I'm going to just say variable because it's going to be one type of variable, to one side and the numbers to the opposite side. Step number 6 is going to be your question. Did you meet your objective? Is your x, is your variable, let's say that, by itself? Did you solve for your variable? And this question just basically asks you, hey, did you do what the question asks you? And are you actually done? So let's go ahead and go through these steps one more time with the secondary example. So let's do example number 2. And for example number 2, let's do a different question here. All right, let's do -5a plus 2 minus 6a is equal to 13. Step number 1 is to draw that dotted line. Step number 2 is look at each section and combine like terms. So I'm looking, there's nothing to combine here. 13 is the only number here. Do I have any like terms? I do. I have a negative 5a and I have a negative 6a. Remember? Watch my combining like terms video. That sign always goes to the number behind it. So I have negative 5 and I have negative 6a. So what does that give you? That gives me negative 11a's. Now I still have this plus 2, so I have to bring this plus 2 down here. I did nothing with my 13, so I'm adding my 13 to my right-hand side. So step number 1, dash line. Step number 2, combine like terms. Step number 3, put your variable in a bubble. Here's my bubble. Step number 4, undo everything attached to your variable. Okay, and remember, it's reverse PEMDAS, so subtraction, addition, division, multiplication, exponents, and parentheses. So is there anything here that we can do? So I'm going back here and it's addition. The first thing I see is addition, so I'm going to undo addition. How do I undo addition? And undoing addition is by subtracting. So I'm going to subtract 2 and I'm going to subtract 2. Sometimes you'll see it rewritten. Sometimes you'll see a teacher put a line underneath. So I'm going to do it in both ways. So in this example, I'll do it here. And then we say cancel. It's not really canceling out. It undoes itself, okay? So having $2 and taking away $2 undoes you having your $2. So these undo each other. So we have 0. We did nothing to our 11a to bring it down. We did do something on this side. So what is 13 minus 2? 13, 12, 11. So I have positive 11. Okay. Step number 5, move the variable to one side and the numbers to the opposite side. So my variable, it is in the bubble, still in the bubble. It's on one side. My number is on the other side. 11, negative 11, this one right here still attached to A. We haven't done anything with it. So we have to undo this negative 11. Again, how are numbers and letters attached here? By multiplication. So I'm going to rewrite this as negative 11 times A is equal to 11. Don't forget that your dashed vertical line is representing your equals 11. So how do we undo multiplication? We're going to undo multiplication by division by that same number. So if it's being multiplied by negative 11, we're going to divide by negative 11 both sides. Okay, you have to have this matching. So if this is negative 11, this is negative 11. Make sure that you are still having your variable in a bubble, so that way you know that you are undoing the correct side, so you don't get confused and undo or divide the wrong number. Okay, so this is same number on top, same number at the bottom. That reduces to 1. So I just have A left over. I have my equals, and then I have to simplify this, okay? I have 11 and 11. So again, if you're in my class, you should know that this same number, top and bottom, gets reduced to 1. So now I have a 1 on top, 1 in the bottom. Same number on top, same number in the bottom is 1. And then I still have this negative. So I have 1 negative, I'm going to bring over. 1 divided by 1, how many times does 1 go into 1? If you didn't say that, same question, how many times does 11 go into 11? And that is 1 time, and you have your final answer. You are now at step number 6. Is your variable by itself? Yes. Did you solve for your variable? Yes. So therefore, you are done. Now, going back to this step right here, negative 11a is equal to 11. We kind of went back to step number 4. So we did step number 4 twice because if I did step number 4 once, got down to step number 6, and I'm here at step number 6, is your variable by itself? Well, no, it's still attached to this negative 11. So then we're going to go back to step number 4. So let's add that to our step number 6. So is your variable by itself? And if you answer yes, you are done. Now, if you answer no, I'm going to tell you to go back to step 4 and continue solving. Oops. All right, let's do another example. I'm going to try to kick these up a notch. Again, super duper important for integrated math 1, for algebra, for any other math class you will ever take. Solving equations is so important. I can't stress this enough. So if you are struggling with this, definitely come in for tutoring. Let me know if you have any questions. And then let's do more examples. Let's do a couple more. So we are on example 3. In example 3, let's do one that has 1 is equal to 4 plus a minus, let's do plus 2. And don't worry about the equals being on the left-hand side, the steps still work. So I have the steps in front of me, there they are, and I'm reading them. If you can, please go ahead and read with me. Step number 1 is draw your dashed line. Step number 2, look at each section and combine like terms. So what do I have? In my left-hand side, I don't have anything except this 1, so there's nothing to combine. But on this side, I have 2 numbers. I have a 4 and I have a positive 2. Remember, you are taking the sign that is in front of it. So I have 4 and 2. So if you have $4 and $2, what do you have? $6. And again, mathematicians are what? They are lazy. So I am not putting that plus, just like there was no plus in front of 4. I'm not putting a plus in front of 6. That is implied. Okay, we did nothing to our A. There's nothing to combine with it. So I'm going to bring down my A. And I'm going to bring down my 1 because we did nothing to 1 on this side. All right. Step number 3, put your variable in a bubble. Make sure you grab the sign with it. Step number 4 is undo everything attached to your variable. One thing that I just did that I want to stress is always, so when you are placing, when placing variable in a bubble, make sure to grab the sign. And that's going to be in our thinking bubble. So whenever you are taking your variable and putting it in a bubble, make sure that you are grabbing that sign in front of it. It's always going to be the sign in front. Okay, now what do we say mathematicians are? Mathematicians are lazy. Okay, so since mathematicians are lazy, remember there was this plus in front of 6 that I was lazy to write. I'm going to put that in. And the reason I'm doing is that I'm looking at step number 4 and it says undo everything attached to your variable. So these are attached. And so it's like, how are they attached? So we want to undo things. So if plus A is in a bubble, I need to undo whatever this is. I need to get rid of this by moving it to the other side. So how do I do that? Well, I take a look at this term and see what it is. This term is positive 6. So what is the opposite? What is the inverse of a positive 6? Well, the opposite of positive 6 is a minus 6. So I'm going to do minus 6 here. And I'm going to do, again, you must do that on both sides. And I did the same step as I did in example number 2. I'll show you maybe in example number 3 if I remember to do it the other way. So same number, opposites, undo each other. I did nothing with my plus A, so I'm going to bring my plus A down here. I did do something on my left-hand side. I said 1 take away 6, that is a negative 5. I have a positive A. Again, mathematicians are what? They're lazy. So we're going to take away this plus. We don't need it. And then we're going to say negative 5. Step number 6. Is your variable by itself? Yes. Did you solve for your variable? Yes. So we are done with example number 3. Let's try example number 4. Now this one I'm going to warn you in advance. There's going to be multiple ways of doing this. I'm going to show you how to do this in two ways. Okay, here's our example. 125 is equal to 5 parenthesis 1 plus 3p parenthesis. So the first way I'm going to show you is I'm going to show you with division. This is kind of where step number 4 fails with division, okay? So let's rewrite it. I have 125 is equal to 5, 1 plus 3p. Okay. If you go back to my one-step equations, you're going to notice that multiplication can be written in many different ways. One of those ways that you can write multiplication is having a number next to parentheses. So if you have a number next to parentheses, that tells you that you have multiplication. So I'm going to put a dot here. Step number 1 always stays the same. The only thing that's going to change here is step number 4. So here's our dotted line. Step number 2, look at each section and combine like terms. I'm looking here and I see a 5 times. I also see this parenthesis. There's not much that we can combine here unless we do this other step that we're going to do on the other example. So we're going to leave it. Put your variable in a bubble. We can still do that. Here's our variable. It's in a bubble. So this is where I'm going to show you a trick. You don't have to do it this way. You don't have to see it this way, but I'm going to show you in case you want this shortcut. This is a shortcut. So because we have 5 times something, right? This is your something. This is 5 times something. We're going to undo that. And so instead of saying 5 times something, I'm going to undo that by saying 5 divided by. So I'm going to say 5 divided by 5. I still have my times. 1 plus 3p. 125 divided by 5. Again, those 5s have to match. What I do to one side, I have to do to the other. So if I'm dividing by 5 on one side, I'm dividing by 5 on the other side. Okay. Now, the reason this works is because I know that 125 is divisible by 5. What that means is I know that 5 times something is 125. Okay. So I know that, and that's the trick. If you can see that, if you know that 5 or whatever, this number goes into this number evenly, then you can do that. Now, if you don't know, then we're going to fix that on this step. Okay, here it is. I'm going to put in a thinking bubble and just say we can do this since 125 is divisible by 5. Okay, so 5 times what is 125? I'm going to do another thinking bubble, and I'm going to try to divide 125 by 5. 5 goes into 1 0 times. 5 goes into 12 2 times, so that's going to be a 10. I'm going to subtract. So then this is 0, this is 2, bring down the 5. 5 goes into 25 5 times. So this 125 divided by 5 is 25. My 5s, excuse me, my 5s go away. And so what am I left over with? I am left over with my 1 plus 3p. My variable is still in a bubble. Now I'm going back to my original step number 4, and I'm going to isolate my variable. I'm going to get my variable by itself. First thing I have is subtraction or addition. Make sure that you know that this plus belongs to this 3 that is attached to p by multiplication, and 1 has a invisible sign that is in front of 1 that is a plus, because mathematicians are lazy and we're not going to put that there. Okay, so the first thing I have to undo is this right here. So I'm going to undo 1 by subtracting 1 both sides. 25 minus 1 is 24. I'm going to bring down the positive 3p, 3 times p. Again, I'm not going to write plus because it is implied. So 3 times p, I'm going to say 3 divided by 3 times p, 24 divided by 3 times p, same numbers, cross them out. P is then equal to 24, which is divided by 3, and that is 8. Is your variable by itself? Yes. Therefore, you are done. So that is one way of doing that, is that you use division first. It's a little bit different than the steps that I provided to you in the beginning of this video, but it still works. All right, let's do the second step, the second way. And this second way makes you use the distributive property. If you don't know what the distributive property, I'm pretty sure I have a video up on that. If I don't, then I will post one shortly. But I'll show you what the distributive property in this example, because we are going to be using it. So let me write out what we originally have. Originally we have 125 is equal to 5 times 1 plus 3p. And what the distributive property does, let's take care of step number 1 first with our dotted line. Make sure we have our equation split into 2 pieces. So what the distributive property does is says, since 5 times 1 and 3p is what we have, we're going to do that. We're going to say 5 times 1 and 5 times 3p. So what I really have is 5 times 1 and 5 times 3p. So then what I really have is 5 times 1 is 5, and 5 times 3, that's 15. And then we have our p. And now we're back at step number 2. Look at each section and combine your variables. So there's nothing to combine. I have a 15 attached to a p by multiplication, so we can't do anything there. I have a positive 5 here. I have a 125, so can't do anything. So now we're back to our original step number 4, being undoing things. So then this one here, I'm going to undo by subtracting 5. Did it again. 125 minus 5, so this is the other way of doing it. And then here you would have positive 5 minus 5 plus 15p. I just want to show you how a different way of writing this out. So instead of doing it on top of each other, sometimes you'll see it next to each other. So 125 minus 5 is 120. Remember, this dotted line represents an equals. 5 minus 5, that's 0. So all we have is 15p. So then I'm going to say 120 divided by 15. I'm going to divide 15 by both sides. So I'm going to say 15 divided by 15 times p. Again, mathematicians are lazy, so there's a secret times there. And I'm going to say 120 divided by 15. Again, your dividing by number has to be the same, and it has to be by the number that is attached to your variable. I kind of forgot to put my variable in a bubble, but it is in a bubble. Okay, so same number top and bottom, that goes away. And then this one here, 15 times what is 120. I'm going to cheat a little bit and say, since it is the same problem, our answer is 8. All right, beautiful people, I hope this has been helpful. If you have any questions, please let me know. Go ahead and set up a tutoring time. I hope that you have enjoyed this video. Please like, share, and subscribe, and tell all your friends about it, how wonderful these videos are. Thank you again whoa, did you hear me? Let's try that again. Thank you again for watching.